Okay, this is section 1.3 of Algebra. So a square root. A number a is a square root of a number b if a squared is equal to b. So 7 is a square root of 49 because 7 squared is equal to 49. The radical symbol, that guy right there, indicates a non-negative square root, also called a principal square root. The expression under the radical symbol is called the radicand. Together, the radical symbol and the radicand form a radical. You will learn about negative square roots later on in a couple sections. Okay, so we're going to simplify square roots. So the square root of 81 is equal to 9 because 9 squared is equal to 81. So 9 is a square root of 81. The square root of 9/16 is equal to 3/4. 3/4 squared is equal to 9/16. So 3/4 is a square root of 9/16. Okay. Square root of 64 is equal to 8. 8 squared is equal to 64. Square root of 25 is equal to 5. It's 5 squared is equal to 25. The square root of 1/36, so 1/36 is equal to 1/6. 1/6 squared is equal to 1/36. And finally, the square root of 81/121 is equal to 9/11. 9/11 squared is equal to 81/121. Okay, and when we square an integer, we call that a perfect square. So 49 is a perfect square because 7 squared is 49. So 2 squared is 4, 3 squared is 9, 4 squared is 16. So 4, 9, and 16 are all perfect squares. If we don't have a perfect square, we can estimate it. So, if we need to estimate the square root of 386, we need to find the two closest perfect squares. So 19 squared is equal to 361, and 20 squared is equal to 400. 386 is a little bit closer to 400, so the square root of 386 is approximately 40. We use that squiggly equal sign to mean approximately. And then we can check it using our calculator as well. So, if we're looking at the square root of 34, 5 squared is equal to 25, and 6 squared is equal to 36, and 34 falls in between there. It's closer to 36, so the square root of 34 is approximately 36. Oh, excuse me, not 36, approximately 6, because 6 squared is equal to 36. Okay, we can classify numbers using sets. A set is a well-defined collection of objects, and each object in the set is called an element of the set. And we call a subset of a set something that contains elements from the set. Okay, so rational numbers are any numbers that you can write in the form a over b, so in the form of a fraction, where a and b are integers and b is not 0 because it's illegal to divide by 0. So, either a rational number has a terminating decimal, a decimal that ends, or it has a repeating decimal. The natural numbers are 1, 2, 3, 4, 5, and so on. The whole numbers are the natural numbers plus 0, so it's 0, 1, 2, 3, 4, 5, and so on. And the integers are the whole numbers but with the negative numbers. So -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, etc. An irrational number cannot be written as a fraction. And irrational numbers do not terminate or repeat. So there are two examples there. So either a number is rational or it's irrational. It can't be both. And when we use square roots, some square roots are rational. So the square root of 4 is 2. 2 is a rational number because it can be written as a fraction, 2 over 1. And 25, the square root of 25 is rational because it's equal to 5. But the square root of 3 is irrational because it's 1.73205080, it keeps going. And the same thing with the square root of 10. Rational numbers and irrational numbers form the set of real numbers. So here's a picture to go with it. This whole thing is real numbers. And within that we have the irrational numbers over here. And this chunk, which is all the rational numbers. And then within the rational numbers we have the integers, the whole numbers, and the natural numbers. So 15, the number 15, is a natural number, and it's a whole number, and it's an integer, and it's a rational number. Negative 1.4583 is a rational number since it has a terminating decimal. It has a decimal that ends. And the square root of 57 is an irrational number since it's not a perfect square. So why don't we try a few? The square root of 9 is 3. So it is rational. It is an integer. It is a whole number. And it is a natural number. Okay, and then B, 3/10 is a rational number because it's written as a fraction. C, negative 0.45 is rational.